Okay, I'm going to start with all of Unit 7 since we haven't seen that one in a while. So really the quickest way to do standard deviation is by using your calculator. So to put the numbers in your list, you go to Stat, Edit, hit Enter, and go ahead and list them into List 1. Once you've listed them, put them all in, you will go to Stat, go over to Calc, one variable statistics, Enter, Enter, Enter. You got to make sure your frequency list is cleared. Calculate, and it will give you your two values that will be your mean and your standard deviation. So remember, standard deviation is your X bar, and then that's your mean. Standard deviation is this funny looking sideways 6. So we can go back to here. We know that, oops, I forgot what those numbers were. We got 73.75, and our standard deviation is 20.48. I'm just going to do 2 decimal places. So here, 73.75, 20.48. So the next problem is asking what happens to the mean and standard deviation if you add a score of 96 to these guys. So to do that, we're going to have to draw our spread. So we know our mean is 73.75. I want to do one standard deviation above and one below. So that means I'm going to take 73.75 and add 20.48, and I'm going to take the mean and subtract 20.48. So 73.75 plus 20.48 would give me 94.23. Remember, standard deviation tells me how spread out I am from the mean. And below I would get 53.27. So that's how spread out our data. And it's pretty big spread because we have a really low test grade in there that's getting it a little wider. So 96 would occur right here. Now, we know for sure that's going to take our average. If you score a grade that's higher than your average itself is going to go up. And your standard deviation itself, it's bigger than your initial spread, so it's going to make your standard deviation increase as well. If we add a point inside our spread, that would decrease our standard deviation, right? And you got to remember, if you score something above your average, it's going to bring it up, and below it, it will bring it down. So going back to the problem, both of these two would increase. Now, moving on, the empirical rule. This is what tells us that our data is normal. That will always be the 68, 95, and 99.7. So you can draw your curve with your mean, and I would memorize this if you don't. If you add 3 standard deviations above and below, 34% of your data is here because that's a total of 68. Then you got 13.5, 2.35, that's really hard to see. I'm going to redraw that. And 0.15 on both sides. These are symmetric. So that brings me to number 4, which tells me that I have a normal distribution with a mean of 74 and a standard deviation of 4. So I've got to see how many students scored more than 86 points. So I'm going to go ahead, go back to this page and give me some room so I can draw my curve. I know it's normal, so I know that my data is going to be this bell-shaped curve with a mean of 74, so that's my middle, and a standard deviation of 4. So on both sides, to add 1 standard deviation would be a 78. Add 4 again would give you 82. Add 4 again would give you 86. And then if you go below your mean, then we're subtracting. So that's 70, 66, 62. So this will be a little bit bigger, but this is the part you need to know. If it follows the empirical rule, then I know the middle here, or 1 standard deviation away, is a total of 68%, or 34 and 34. This is 13.5, 2.35, 0.15, and then the same on the other side. 13.5, 2.35, and 0.15. So if it follows the empirical rule, those percentages will always be true. So it wanted me to find the area above 86. So how many students scored above 86 points? And for this one, above 86 would equal 0.15%. Now that's not actually on there. This one was a typo. So for your answer for this one, none of these actually work. The answer should be 0.15. So sorry about that one. But now we can use that same bell curve we used before to find number 5, which is 74, between 74 and 82. So between 74 and 82 would be 74, 82 would be this much percent. So if I add those two together, because that's 74 and 82, it's right between, that would give me 47.5%. So going back, the answer to number 5, using the same thing, would have to be A, 47.5%. Now, we know that it will not always be able to use the empirical rule to find this, but we have our standard normal, or our z-score, that we can calculate if it does not hit exactly on a standard deviation. So that's what number 6 and number 7 are. You have to calculate the z-scores to show, because you're not going to be able to hit exactly on those standard deviations. And let me show you what I mean. So we have a mean of 1,020 words per minute when typing, and a standard deviation of 90. So it says it follows a normal standard deviation, so I'm going to draw my curve. There's my mean, or my x-bar. I'm going to draw my bell shape, and I'm going to start doing 3 standard deviations above. So I'm going to take 1020, and I'm going to add 90, which I'm going to get 1,110. I'm going to keep adding 90. That's 2 standard deviations above. Add 90 again, and then that's going to give me 3 standard deviations above. But then I also have to do below. So I'm going to start subtracting 90. Should give me 930. Then I'm going to subtract 90 again, giving me 2 standard deviations below. And then last one, subtract 90 and get 750. So this is my normal curve. But if you look in question 6, it's asking me to find the probability that it's less than 939 words per minute. So if you look here, 939 words per minute does not hit exactly on a standard deviation. So we cannot use our empirical rule. So we have to use our z-score formula, which is x minus x bar over standard deviation. X is what they're asking me, so that was my 939. X bar is my my mean, and the little thing on the bottom, that's our standard deviation, which was 90. So we've got to calculate the z-score and find the probability that way, and that's on the table at the very back of this packet. So I'm going to do 939 minus 1020, get negative 81 and divide by 90. We got to make sure we do 2 decimal places because the z-score table tells me 2 decimal places. So I'm going to go all the way to the back. Let me see if I have this. So I'm looking for when my z-score. Let's see if I have it on the end. Oh, no, I don't. So you'll have to look at it in front of your eyes right now. Where'd it go? Oh, there it is. So negative 0.90, and remember our z-score tables only tell me what is below. Negative 9.0, I'm going to go down on the left side to negative 0.9, go over 1 because it's 0, and you will get 0.1841. That would be the probability. So your answer for this guy would be A. Now B is using the same data, number 6. We've got to find when it's greater than 1220. Again, 1220 does not fall right on 1 standard deviation, so I'm going to have to use my z-score. But it is telling me above. If I am doing above, I've got to take the total probability of the curve, which is 100% or 1, and subtract from whatever the probability is below it. So I'm going to find the z-score at 1220, but once I found the probability in my table, I'm going to subtract it from 1. So my z-score, my x now is 1220. I still have the same mean, which is 1020. And I'm going to divide it by this still the same standard deviation, which is 90. So 1220 minus 1020 divided by 90 gives me 2.22, rounding 2 decimal places. And back on my z-score table, 2.22, I'm going to go over and then go over right twice. That's 0.9868. But that's not my answer. Do not stop there. Since we're above, again, I've got to take that and subtract it from 1 because I'm trying to find the little area above. So 1 minus 0.9868 is going to be 0.0132. So if we go back, that would be B. Don't automatically pick D. That would be if we were finding the probability below 1220. So I will go back to your first test and your packet of Unit 7 to help you out with this, but these are all the questions that are going to be like that on the test.